Let's take a look at how to graph polynomials. And when I talk about graphing, I'm not talking about making a super accurate type of a graph like you might see on a graphing calculator, but rather sketching a graph that gives us the important information such as the location of the zeros, the basic shape of the graph, what it's doing near the x-axis, the end behavior, and so on. We can use graphs like this to solve equations and inequalities graphically without having to do a lot of the algebra work that we would have to do with other methods. So the first thing we want to do is to consider whether or not we've got our polynomial in expanded form or factored form. And so we'll take a look at both forms here and see how we get to where we need to get in order to get started. And what we need to begin with is the leading term. And the leading term, of course, in this case is going to be 2x to the fourth power. And the reason we need the leading term is because that's what determines our end behavior. Remember that the end behavior is determined by two things in the leading term: whether the degree is even or odd, and whether the leading coefficient is positive or negative. Okay, the rest of the polynomial doesn't matter in terms of the end behavior. Which way does the graph approach from negative infinity, from positive infinity? If we have a factored polynomial, we're going to have to build the leading term. And the way that we do this is as follows. I have 2x times a factor x plus 1, which is squared, and another factor x minus 2. And so in order to build the leading term, I'm going to get the leading terms of each of the pieces. And I'm also going to include any number that I have out here. And if this happened to be negative, I would include the negative sign as well. One last little detail: if I have a factor such as this one that is raised to a power other than 1, okay, this one is raised to the second power, I need to take that into consideration as well. And so now I'm just going to multiply all these together. So I'm going to have 2 times x squared times x again. And if I simplify this, 2 stays here. We have x times x times x times x. That's 4 x's. That's 2x to the fourth. And that gives me the same thing that I have here. So building the leading term is the first thing we need to do if we have a factored polynomial. If we have an expanded polynomial, then the leading term is already built, it's already supplied for us in the expression for the polynomial. Okay, so the next thing we want to do is to get the polynomial into factored form. And we've looked at different ways to factor polynomials, and I'm going to just leave it at that and say if we have an expanded form, we need to factor it. I'm not going to go into the factoring techniques in this video, but we'll go from this form down to this form. And once we do that, now we know that we've got our zeros available. Okay, so let's get our end behavior taken care of here first. Notice we have a positive leading coefficient and we have an even degree. And so for this particular one, we have positive leading coefficient, even degree, and that gives us this end behavior. Okay, so I'm just going to make a little sketch right here to keep track of that. Next thing I want to do is to get my zeros. So to get the zeros of the graph, I'm going to look at each of the individual factors up here and find out when do they equal 0. Well, 2 never equals 0, so I don't have to worry about that, of course. X equals 0 when x equals 0, of course. So there's really nothing to do there except just to write that down. Let me put this here. We're making a list of the zeros in this case. For this factor, this equals 0 when x is equal to -1, so -1 plus 1 equals 0. So I'm going to have x equals -1. And then for this factor, x equals 2. Now the other thing I want to list here is the multiplicity of each zero. And what I mean by the multiplicity is how many times does this factor appear. And we'll see in a second that that's going to be important in drawing the graph. And so let's see what it is we mean by that. If I look at this factored polynomial up here, I could actually write this as 2x times x plus 1 times x plus 1 times x minus 2. So this pair of factors, which is actually the same factor put in here twice, comes from the fact that I have x plus 1 squared here. Anything squared is just that thing times itself. And if it happened to be raised to the third power, I could write it 3 times. If it was raised to the 12th power, I'd write it 12 times, and so forth. So the multiplicity refers to how many times does each factor appear. And so I see that my x, which gives me the x equals 0, 0, appears 1 time. My x equals negative 1, which comes from the x plus 1 factor, appears twice. And my x minus 2 gives me a 0 of x equals 2. That appears once. So the multiplicities are said to be 1 for x equals 0, 2 for x equals negative 1, and 1 for x equals 2. Okay, so now that that's out of the way, let's go ahead and draw the actual graph. So I will start by drawing an x-axis and a y-axis. Now notice that none of this is going to be super accurate. I'm going to try to draw this more or less to scale just by eye, putting stuff in the correct side of the y-axis for negative and positive, of course, and trying to put things roughly in the right place, but I'm not going to stress too much over making things exact. Certainly not going to get out a ruler or anything like that. So let's go ahead and plot the zeros first. We know we have a 0 at x equals 0. That's the origin, and I'll just mark that 0 here. We have another one at x equals negative 1. I'll just pick a spot for it, negative 1. And then we have our third 0 at x equals 2. So I'll go out here approximately where 2 would be and mark that in place. Okay, so now that I've got the zeros in place, I want to go ahead and take a look at the end behavior and see what I need to do with that in terms of the graph. The end behavior shows me what the ends of my graph are going to do. And so I know that as I get farther and farther to the left on this graph, that the graph itself will be going upward. And it starts at the leftmost 0. I'm going to put that arrow right here. The reason is because I know that this is the last place going to the left that this graph is going to touch or cross the x-axis. I know that because this is the list of all of the zeros. If I had another place where it would come back and touch the x-axis, then I would have another 0 here. But since I don't, I know that this graph is going to just go ahead and start doing its end behavior thing. Same thing on this side. I'm going to use this arrow over here at 2. Okay, so now I want to go ahead and fill in whatever happens in between here. And this is where the multiplicities of the zeros come into place. I want to start over here on the left at x equals negative 1. I'm going to find that 0 here, and I see that I have a multiplicity of 2. So if I have an even multiplicity, the graph is going to bounce, is the word I like to use, off of the x-axis. In other words, it will touch and turn around. So if you think about a parabola, okay, x squared, a parabola x squared has a multiplicity of 2, and its graph looks like this. In fact, the parent function touches the x-axis right there at the origin. Okay, so that's a little bit of a model that you might be able to use to try to remember how that works. If I have odd multiplicity, then the graph crosses the x-axis. And so my next 0 going to the right here is x equals 0. I have a multiplicity of 1, which is an odd number. Now I know that my graph is going to be above the x-axis here, so it's going to cross in this direction. I don't really know what it's going to be doing exactly in here, but it really doesn't matter, because all I really care about is whether it's positive or negative, which direction it's going, where it's crossing the x-axis. And then finally, my last 0 is here at x equals 2. It also has a multiplicity of 1, which means that the graph is actually going to just cross through. And that makes sense because I'm on the same side of the x-axis in both cases. And so this little shape here is roughly what the graph would look like. Okay, so again, not a whole lot of detail here, but I know where the graph is positive, I know where it's equal to 0, I know where the graph is negative, I know which way the ends are going, and I can tell at any value of x whether the graph is positive, negative, or 0. Okay, let's try another example here, and I'll go through this probably a little bit quicker so that we can just see what the process is. If you need to review the details, go ahead and restart the video. First thing I want to do is to build my leading term because I have a factored polynomial here. So I've got negative 3, I have x, this x is cubed, and then I have another x, this x is squared, and so that gives me negative 3x to the 5th power. This is an odd degree, and I have a negative leading coefficient, and so my end behavior is going to be in this direction. Okay, so let's go ahead and get the zeros. Negative 3 has no 0, of course, with it. I have a 0 for this factor, which is x equals negative 3. And this has a multiplicity of 3. I'll just make a note out here. This factor has a 0 of positive 1, and its multiplicity is 2. So this is even multiplicity. This is odd multiplicity. And now I'll go ahead and draw my graph. Plot my zeros, negative 3 and 1. So let's go out here to negative 3, out here to 1. I'm going to put my end arrows on the outside zeros, the first and the last one, and they happen to be the only ones in this case. And now I want to see what happens between here and here. Well, at x equals negative 3 on the far left here, I have odd multiplicity, and so the graph will cross. Over here at x equals 1, I have even multiplicity, and so as my graph moves along here, it's going to bounce off. And so that's consistent with my end behavior, and so this graph is going to end up looking like this. Okay, let's try one more with a little bit more complexity to it. First, I'm going to build my leading term. I have 6x. Now here, I have to take this whole term here and square it. So I'm going to have 2x in parentheses squared, and then I have x to the 1. And in order to deal with this then, I'm going to have to square 2 and square x. So I have 6x times 4 times x squared times x. So that comes out of here. And putting that all together gives me 24x to the 4th. This is even. This is positive. My ends go in this direction. Let's get the zeros. I have the first 0 here is going to be x equals 0 because x is by itself. I'm going to skip this one for a second. We'll go on to this one. This should give me x equals negative 2. Okay, both of these are multiplicity of 1, so I'll make a little note of that like this. And now let's take a look at this one here. 2x minus 3 halves equals 0. Because of the presence of this 2 in front of the x, I have to take the long way here. 2x equals 3 halves. I'm going to divide both sides by 2. And I get x equals 3/4. This has a multiplicity of 2. Okay, we'll go ahead and draw the graph now. So I'm going to draw my x-axis, my y-axis. I have a 0 at 0. Let's try a different color here. I have a 0 here. I have one at negative 2. Okay, and I have another one at 3/4. Which will be over at this side. Make that look like a 3, more or less. Okay. Now for the graph itself, I have ends that do this. I'm going to stick this arrow at the far left over here. I'm going to stick this arrow at the far right over here. And now I'm going to start again over here at the left and see what I need to do here. I have a multiplicity of 1, so this crosses here. Multiplicity of 1 at 0, so it crosses. And I have a multiplicity of 2 at 3/4, so I know the graph bounces. Everything looks consistent, and there's a sketch of my graph.